Chapter 10 is basically an introduction to algebra, where we have an equation, which means we have an equal sign in it, and we have a variable, and we can manipulate that equation to find out what the value of the variable is to make the equation true. So the kind of equations that have only one variable are called linear equations, and they are of the form ax plus b equals c. For instance, 4x plus 9 equals 0, and 2x minus 3 equals 5, and x equals 7. Those are all examples of linear equations. Now, if you have an exponent like x squared plus 2x equals 5, or you have a fraction where x is in the denominator, like 1 over x equals 6, or you have an absolute value with x inside the absolute value sign. Those are not linear equations. Those are different kinds of equations. And the difference is you can graph these equations. If you graph a linear equation, you get a line. If you graph a nonlinear equation, it won't be a line. So a solution of an equation is a number that makes the equation true. And a solution set is all of the numbers that make the equation true, which is shown in brackets. We're going to show examples of this in a minute, but if two equations have the same solution, they are called equivalent equations. And when you solve an equation, your goal is to rewrite the equation so that it says x equals a number. Right now we're just laying down some definitions so that we can have the language we're going to talk about when we use equations. Okay, very important, addition principle. That means you can add the same thing to both sides of the equation and you'll still get an equivalent equation. We will use this quite a lot as we work in algebra. So equations are like a balance. You can add or subtract the same thing from each side of the equation and the scale is still balanced. Now this helps us to put the equation in the form of x equals something. So if you look at the first example, x minus 23 equals 8, you can add 23 to both sides and you'll get an equivalent equation, and look what happens. On the left you get x minus 23 plus 23, which leaves you with x equals, and on the right you have 8 plus 23, 31. So you have a solution now. You have x equals 31. You have manipulated your equation so that it's in the form of x equals a number. And the way you write your solution set is inside of brackets, like this. Now if you look up for a minute, you see the bullet point, if a is a number and negative x equals a, then x equals, and the answer is negative a. And examples of this are, if you have a solution negative x equals 5, then you can rewrite that to say x equals negative 5. Okay, so let's look at the rest of the examples. In fact, I want you to do the rest of the examples and see if you can find the solution. I will do this last one over here for you. So pause the video and work these examples. Okay, so for the first example, your answer should have been y equals 6.2. On the next problem, we can add 12 to both sides, but then we get 0 equals z plus 5. We do not have it in the form of z equals a number. Now we can do one of two things now. We can subtract 5 from both sides, or we can subtract z from both sides. The most efficient way is to subtract 5 from both sides, but I'm going to do it the other way so that I can demonstrate something. So we subtract z from both sides, and we get negative z on the left equals 5 on the right. Now we use this principle that if negative x equals a, then x equals negative a, and we come back down here and rewrite z equals negative 5, and so our solution set is negative 5. The last example, we have 4a plus 8 equals 3a. So we subtract 8 from both sides, and we get 4a equals 3a minus 8. Doesn't look like we've cleaned up anything very much, so let's try subtracting 3a from both sides, and we get that a equals minus 8. So we had to do 2 steps, and one of the steps is, since we had a variable on both sides of the equation, we needed to subtract the variable term. Now, a term in an equation like this, where we have 4a is a term, 8 is a term, and 3a is a term. Terms are separated by pluses and minuses. So that's how you define a term, and I'll be referring to that a lot. So your solution set is negative 8. Okay, in your textbook there are problems that you can practice on. If you turn to page 681, you will see some problems in a column on either the right side or the left side of the page, and you can solve those problems, and then at the bottom of the column are the answers. I like this cartoon because it illustrates the difference between what you know about regular arithmetic versus algebra. The poor student is very frustrated because yesterday the teacher said that x was equal to 2. Okay, so let's go on. As we illustrated in an early example, sometimes we use the addition property twice to solve an equation. Sometimes we even will do it more than that. So in this case, look at this equation. Try adding 7p to both sides and see what you get, and then try subtracting 8 from both sides and see what you get. Pause the video and try that. So your solution should be that p equals negative 3. Many equations can be simplified before solving by combining like terms. So in this example, you can combine your t's, and then you can combine your numbers, and then you can solve it the way we've been solving it. So go ahead and combine your like terms, pause the video, and then check back to see if you got the right answer. So this is what you should have gotten from combining like terms, but we haven't solved the equation yet. We need to get all of our variable terms on one side and then all of our numbers on the other. So to get our variable terms, we subtract 3t from both sides, and we get t minus 10 equals 7, and then we add 10 to both sides to get our variable by itself, and we get t equals 17. We use the distributive property to solve equations where there are parentheses. So in this example, we're going to distribute the 5, and then we're going to distribute the minus sign. I'm going to show you how to do that. So let's go ahead and do this. When you're dealing with subtraction, it's easy to make sign errors. So the best way to guarantee that you don't make sign errors is to change subtraction to addition. And here's how you do this. You rewrite 5, but you have a subtraction in the parentheses. So the way you change it to addition is you change the sign of 3 to be negative 3, and you add a line to your subtraction to make it addition. So you're making 2 changes. One is 3 becomes negative 3, and 2 is subtraction becomes addition. And on the second one, we have a subtraction sign in the middle, which we are going to change to addition. And when we do this, we say plus a negative. So whatever's in the parentheses becomes negative, and whenever you have a negative sign in front of a parentheses, go ahead and change it to a -1. That will help you to distribute it. So we have plus a negative 1 times 11b plus 1 equals 20. So now we can apply our distribution property and we will not make a mistake with negatives. So we have 5 times 2b is 10b plus 5 times negative 3 is negative 15. And don't worry that it looks awkward to have plus negative. Okay, plus, and then negative 1 times 11b is negative 11b plus negative 1 times 1 is negative 1. Okay, now we can combine like terms. 10b plus negative 11b is going to be negative b. 15, or negative 15 plus negative 1 is going to be minus 16. And we can go ahead and either say plus a negative 16 or go ahead and write it out as minus 16, because at this point all of our terms will be combined and we've gotten rid of the parentheses. And on the right side we have 20. Now we can add 16 to both sides. And we get, I'm going to come over here, negative b equals 36. And as we learned before, if negative b equals something, b equals the opposite of that. So b equals negative 36. So our solution set is negative 36. Okay, so practice this on page 683 doing those exercises. In the same way that the addition property allows us to add the same number to both sides of the equation, or the same variable term, we can do the same thing with multiplication. We can multiply both sides of the equation, or we can divide both sides of the equation by the same thing. So if a is equal to b, then a times c is equal to b times c. And an example is, if you have x equal to y, 3x equals 3y. So in the case where you have a fraction times a variable, then if you multiply both sides by the reciprocal, then you can multiply both sides of the equation by the reciprocal of the fraction to clear the fraction. The reciprocal of 1/3 is 3 over 1. So let's multiply by 3 over 1 times 1/3 x equals, and then we multiply the other side by 3 over 1. Now we're going to just call that 3 because we're multiplying it by a whole number. 3 over 1 is the same thing as 3. So look what happens. On the left, the 3's cancel, and you're left with x by itself, which is what you want. So you get that x equals 12. So you can also divide both sides of an equation without changing the solution. If you have a whole number in front of your x term, then you will want to divide both sides of the equation. Look at 3x equals 15. 3 is a whole number, so if you divide both sides by 3, then you'll be able to get x by itself. Notice that if you divide both sides of the equation, you cannot divide by 0. Dividing by 0 causes cities to explode and craters to appear, so you do not want to do that. So let's divide both sides of the equation by 3. And then the 3's cancel on the left, and you're left with x equals 15 divided by 3 is 5. So your solution set is 5. So you can practice this on page 688. So to review what I just said, if you have a fraction in front of x, like in this first example, 3 over 7 times x equals 4, then you should multiply both sides by the reciprocal. But if you have a whole number like 14x equals 28, then you should divide both sides. Okay, the 14 is called the coefficient of x. So when you have a term like 14x, coefficient means the number in front of x. So let's go ahead and do a couple of examples and then I'll let you do the rest. The reciprocal of 3/7 is 7/3, so we are going to multiply both sides by 7/3. Now whenever you're multiplying a fraction and a whole number, like on the right side we'll have 7/3 times 4, you should change the whole number to a fraction, which would be 4/1. So on the left, everything cancels for the numbers, leaving x by itself. So you have x equals, and then on the right you can reduce nothing, so you can go ahead and multiply the numerators, which is 7 times 4 is 28. Multiply the denominators, which is 3, and there's your answer. Your solution set is 28/3. Okay, so I cleaned up a little bit, and now we look at example 2. We have 14x equals 28, so because we have a whole number, we are going to divide. That gives us 14x over 14 equals 28/14. The 14's cancel and you're left with x equals 2. And then the third, we have a decimal, negative 1.5x, and so we're going to divide by negative 1.5. And 7.5 divided by negative 1.5. So the 1.5's cancel on the left, and 7.5 divided by negative 1.5 is a negative number, and it's going to be 5. Now a little trick you can do with decimals is the decimal point on top and the numerator and the decimal point in the denominator can both be moved as long as you're consistent. So you can move this decimal point over and this one over one place to give you 75/15, which you can know is 5, and then you have that negative sign, which didn't show up very well there. So let me see if I can fix that. Okay, you practice on the next 3 examples, pause the video, and then check your answers. Okay, when your coefficient of the variable, in other words the number in front of the variable, is negative, you want to multiply both sides of the equation by -1. So in the first example, negative k equals negative 15. We already learned that if you have negative k equal to something, then k would be the opposite of that. And the reason for that is you're essentially multiplying both sides by -1. Negative k times -1 is k. Negative 15 times -1 equals 15. And then if we do it as we learned earlier, if negative x equals 49, then x equals negative 49. Same process. And don't forget to combine like terms before you solve. If you have 5m plus 6m, you have to combine the m terms so that you have one variable term on the left side of the equation. So adding those like terms, you get 11m. And now you can divide both sides by 11, and you get m equals 3. So you can practice these on page 689. And this is the end of sections 10.1 and 10.2. So also go ahead and work on your homework for those pages.